Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's easy level puzzle. And to take that easiness with a grain of salt, because it's considered easy by the people on the Logic Masters Germany forum, and there's a lot of really smart people there. Today's puzzle is called True Yin False Yang by the Bard. And here are the rules. We have normal Sudoku rules apply, which is place the digits 1 through 9 in each row, column, and box without repetition. We have yin-yang shading, where we need to shade some cells so that all shaded cells and all unshaded cells form two orthogonally connected areas such that no 2x2 area is entirely shaded or entirely unshaded. And all the clues values in the unshaded areas are liar clues and not true. Interesting. Some cells are shaded and therefore true clues. And each clue is either fully shaded or unshaded. Interesting. So, place the digits 1 through 9 in each row and column and box without rep. Okay, so yin-yang shading. So what does it mean to be an orthogonally connected area? Or as I like to put it, an orthogonally connected region. It means you can go from any cell in that region to any other cell in the region just by going through edges, all while staying within the region. So this is an example of a valid orthogonally connected region because you can go from any cell in the shaded region to any, or it's valid yin-yang shading because you can go from any cell in the shaded region to any other cell in the shaded region just by going through edges while staying within the region. And it works the same way for the unshaded region, where you can go from any cell in the unshaded region to any other cell in the unshaded region just by going through edges, all while staying within the region. What is not valid, though, would be a shading like this, or let's use this one, because if this were shaded now, these cells can no longer get to these cells by going just through edges while staying within the region. In this specific case, they have to go through an edge and exit the region, which obviously doesn't work. And all unshaded cells and all shaded cells form these two orthogonally connected areas. This is also not a valid shading because we now have a 2x2 area that is entirely shaded, and no 2x2 area can be entirely shaded or unshaded. And we also have, we know clues values in unshaded areas are liar's clues and therefore not true. So, for example, this doesn't quite work because these two cells should be the same shading no matter what. But we know these two cells are correct, right? If this was a valid shading, these would be fully correct, these would be fully correct, as would these. And these would not be correct, so these would not add up to 10 as a value. So what are the clues we have? We have XV pairs, where digits separated by an X sum to 10 and digits separated by a V sum to 5. But again, remember, this is only true for the shaded cells. It's untrue. It's not true. It cannot be true for the unshaded cells. So in this case, these two cells must add up to 5 because they are in the shaded region. These two digits must add up to 10, so must these two because they are also in the shaded regions. But these two cannot add up to 5 because they are in the unshaded regions, assuming this is the correct shading. And these two also cannot add up to 10 because these are in the unshaded region. So, for example, if this were, say, a 3 here, this would have to be 7 because these digits must add up to 10 because they are in the shaded region and there's an X between them. Same with this. If this were 3 and this would have to be a 2 because they are in the shaded region and there's a V between them. But if we had a 3 here, this could not be a 2 here, because they cannot add up to 5, because they are in the unshaded region, and therefore not true. So that's how XV pairs work. We have arrows, where digits on an arrow must sum to the digit placed in that arrow's circle. And again, they are all going to be part of the same region. So if they had an arrow where these were correct, they would add up to that digit, but again, we don't know. So these are all in the same region. These are in the same region. So if this were, say, 3 and, or let's say, that's a lot of 3s and 4. If we had 5 and 3 here, this would have to be 8, because the 2 digits on the arrow must add up to 8, because they are all in the shaded region. And that's an example of how arrows work. And we have crop key pairs, where digits separated by a black dot must be in a 2-to-1 ratio, and digits separated by a white dot must be consecutive. So, for example, if this were, say, a 2 here, this would have to be 1 or 4 to make sure that this is in a 1-to-2 ratio here. And if this were, say, a 6 here, this would have to be 5 or 7, because they need to be consecutive, because there's a white dot between them, and they are in the shaded region. So, keep that in mind. Anyways, those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay. So these are all the same shading. These are all the same shapes. These are definitely shaded. This is definitely shaded. In a yin-yang shading, we know the edge of the grid can only change shadings 0 times or 2 times. And the reason why is if you tried to change more than that, well, first of all, you can't do any odd digits, because that just doesn't make any sense, right? If you change shadings once here, the problem is you have to eventually change back. So that's why you can never have odd amounts of changes of shading on the edge of the grid. If you change once, you have to change back to the other type of shading, right? But one thing you also know, or this is actually something you can deduce, well, specifically just by looking at geometry, is you cannot have more than 2 changes of shading. You could have 0 or 2, but you cannot have more than 2 on the edge of the grid. And it's basically just pure logic. How do you orthogonally connect the green regions without breaking apart the blue regions into 2 separate regions? And the answer is you can't if you have more than 2 changes of shading. Or if you try to orthogonally connect the blue regions, you will necessarily break the green regions into 2 separate regions, which obviously does not work, because you must have only 2 fully orthogonally connected regions for these shadings. So once you have a change of shading, once you have 2 changes of shading, you know that you cannot have any more. So in column 9, we know you cannot have 3 changes of shading there. You cannot have 3 sets of digits adding up to 5. There's at most 2. So we know one of these has to be false at least. It could be all 3 of them are false. But one of these is at least false, which means it must be unshaded. Well, that's a change of shading from this shaded cell here. That means we cannot have a change of shading at all here between here and here, because we are guaranteed there's a change of shading here, and there must be another change of shading between here and this cell here. So that means we cannot have a change of shading in any of these cells, So we know all of these are all of these have to be shaded. So this is shaded, that's shaded, this is shaded. And this is a 2 by 2 area that's all shaded because if each clue is either fully shaded or unshaded, right? So this area, these have to all be shaded. So since these are all shaded, this must be shaded and this must be shaded for that to work. So we have a 2 by 2 area here, which now is all shaded, which means this cannot be shaded. It must be unshaded since this is a 2 by 2 that's all shaded. It has to be unshaded there. This is unshaded because of the 2 by 2 area here. Same with this 2 by 2 area. This must be unshaded. And it has to exit out, so it must be unshaded to there. These are the same shading, and we have a 2 by 2 area that's all shaded, so this can't be unshaded. This can't be shaded, it must be unshaded. That means this is also unshaded here. So we have a change of shading here. We don't know about this, though. So these must add up to 5 guaranteed. So we have 1 and 4 or 2 and 3 there. These cannot add up to 5, but that's not very helpful. These add up to 5, so that's 1, 4, 2, 3 there. One out of these... Okay, so whatever this shading is, it's all the same shading here. And it has to be opposite of this shading here. So let's make that red. This is shaded a different shade. It's pink. That means this must be the opposite shading because we have a 2 by 2 area that's all the same shading. So I'll make that red. This is the same shading. Therefore, this must be pink. Oh, and another thing, in yin-yang shading, another thing you can deduce is if you have a diagonal that is one shade, you cannot have the other diagonal be the same color as each other. So you can't obviously have these be both orange if this is the case, right? Because then this is 2 by 2 area is all the same shading. But you also cannot have this be the opposite color and both of these being the same color, right? Because why is that? Because if you try to orthogonally connect either the yellows or the oranges together here, you will necessarily break apart the other shading into multiple regions at least. Right? If you orthogonally connect the yellows, the oranges will be broken up into 2 regions. If you try to orthogonally connect the oranges here, you will necessarily break apart the yellows into 2 orthogonally connected regions, which is not allowed. So since we have a pink and a pink here, this cannot be pink. It has to be, it can't be red because these can't be the same shade. So this must be pink also, which makes that pink there. Well, what do we have here then? We cannot... We have a 2 by 2 area that's all pink. This can't be pink, so it's red. If this were pink here, the problem with that is this 2 by 2 area would have 3 pinks, so this would have to be red. But we have a change of shading here, and then another quick change of shading here, but we know this is already a change of shading here. So that's not going to work. So this cannot be pink. This must be red also. If this is pink, you could have red there, so that's fine. We know these have to be different shades, because if they're the same, then this 2 by 2 area would be the same shading. What else do we have? Hmm. So these are opposite no matter what. But they don't have to be the shading that we have here, right? Um, oh, that's interesting. This is consecutive with this. So this digit has to be 1 through 5 here, guaranteed, for that to work. These are in a 1 to 2 ratio. These two digits add up to this. So, and they're consecutive. So this is cannot be 1, 2, because if this is 1, 2, that would eliminate both possibilities for these cages, these cells here. It could be 2, 3, and 5, because this could be 1, 4. It could be specifically 4, 1, and 8 there. So this could be 2, 3 with 5. It cannot be 3, 4, because that would eliminate all possibilities for this V here. So this is 2, 3, and 5, or this is 4, 5, and 9. We don't know which. Either way, we guaranteed have a 5 in this box be on this arrow. So either this is 2 and 3. This can't be 1, 2, adding up to 3. Cannot be 2, 3. It could be 2, 3, adding up to 5. Cannot be 3, 4, adding up to 7. Could be 4, 5, adding up to 9. We don't know, though. So either, if this is 2, 3, this has to be a 1, 4 pair, which eliminates 4 in the rest of the row. And 2 and 3 would mean 1 and 4 there, but this can't be 1 in that case. So it would have to be 4 and 1 there. This would then be 8. Does that work, is the question. This would obviously have to be 2 remaining digits in this row. So we would be missing 2, 3, 1, and 4. So this is at minimum 5 and 6, which doesn't add up to what a single digit could be. So it cannot be 2 and 3. Therefore, this must be 4 and 5 here, adding up to 9. And this is a 2, 3 pair here. And the problem is to add up to another digit, we have to have a 1 here. If we don't have a 1 here, the minimum here is 6 and 7, adding up to 13. So 1 has to be one of these. 2 is only in a 1 to 2 ratio with 1 or 4. So this can't be 2, which makes this 3, which makes that 2. 3 is in a 1 to 2 ratio with 6. And this is 2, which it must be consecutive with 1 because we have a 3 already in the box. So this is 1, which means this cannot be 1, 4, adding up to 5 here. So this must be not true also. This is either 1, 7, adding up to 8, or 1, 8, adding up to 9. Either way, we are guaranteed an 8 in one of these cells. We are also guaranteed a 1 here, which eliminates 1, 4 as a possibility to add up to 5 here in this box. So that's 2, 3 as a pair. This has to be then 7 or 9 there. So these cannot be true, and because we can't have 1 and 4 adding up to 5 in this box. That means we have a 2 by 2 area that's all green, so this cannot be green, so this must be blue, which means this is blue and blue. And it's in a 1 to 2 ratio. These cannot both be green because we'd have a 2 by 2 area that's all green, so these must be blue also. Remaining digits in this box, in box 1. Cannot have 1, 2, 3, or 8. So it must be 4, 5, 6, 7, 9. And 9 cannot be any of these digits because of 9 in the row. Remaining digits of box 2. We have 1, 2, 3, 7, 8. 1 cannot be here. Oh, interesting. These cannot add up to 10, but we don't know what combination they are. 7 cannot be here because this has to be in a 1-to-2 ratio with another digit, and it's true. This can't be 3 either, because so 5, 7, and 9 can never be next to a black Kropke dot if it's true. Because if you have 5, 7, or 9, you get 2, 3, 2.5, 3.5, 4.5. If you double 5, 7, or 9, you get 10, 14, or 18, none of which are digits. So either this is 1 with 2, 2 with 1 or 4, or 8 with 4. Those are the possibilities here. Okay. But this 2, 3 pair eliminates 2 and 3 in the rest of the row. So no 2, 3 here. This becomes a 1, 7, 8 triplet here. That eliminates 1, 7, 8 in the rest of the box, so this can't be 7 or 8. It's 2 and 3 as a pair here. And this must be 1, 7, 8 guaranteed. Well, 1 and 7 are not in a 1-to-2 ratio, and neither are 7 and 8, and neither are 1 and 8 here. So this has to be false, which means these are both green. Okay. No more 7 here. Remaining digits in this box 3, we have 4 through 9. No 7 or 8 here. No 7 or 8 here. No 9 here because of 9 in the row. These are in a 1-to-2 ratio, but we cannot have 2, 4 be that possibility. We can't have 1, 2 be here because this can't be 1 or 2. And it can't be 2, 4 because that would eliminate all possibilities for that cell. So it could be 3 and 6 or 4 and 8 as a pair. We don't know in a 1-to-2 ratio. Okay. These both have to be true. Because they are the same shading, and if they were both false, green, then this 2x2 area would be all green. So these have to be blue. And we're guaranteed this is either 1, 4 or 2, 3, adding up to 5. That eliminates 2 and 4. And one of these two digits is 2 or 4. We have another digit here that must be 2 or 4 to be in a 1-to-2 ratio with 1 or 8. That eliminates 2 and 4 in the rest of row 4. So this cannot be 4 and 8 anymore. This must be 3 and 6. That eliminates 2 and 3 here. So this is a 1, 4 pair. That eliminates 4 there. So this must be 2. And 2 is in a 1-to-2 ratio with 1 out of 1 or 8. This can't be 1 here because of 1 in the box. 2 eliminates 2 here, so that's 3 and 2. And in this cage, the minimum digits here are 5 and 7, which is never going to add up to a single digit. So this must be false here. And since this is false, these have to be the opposite because otherwise we'd have 2x2 areas, which are 2, which would be all green. So these must be blue here, which means that's blue here because we cannot change colors there. This 2x2 area is all blue, so this must be green here, which means that's green. What else do we have? Remaining digits of row 4 are 5 through 9. These are in a 1-to-2 ratio, and this cannot be 1, 2, or 4. So it could be 3, 6 with 3, 6, or 8 here with 4 there. These can't be consecutive. Remaining digits in box 5 are 3, 6, 7, 8, 9, with 5. And no 9 here because of 9 in the column. No 3 or 6 here because of 3 or 6 in the column. This could be 8 and 4, potentially. We don't know. Okay. 3 is definitely here. 3 is definitely here. 3 has to be one of these 3 digits in column 9. These 3 digits must add up to what this digit is. So cannot be 1, 2, 3 adding up to 6 because that would eliminate all possibilities for that cell there. Could be 1, 2, 4 adding up to 7. Could be 1, 2, 5 or 1, 3, 4 adding up to 9, 8, I should say. This can't be 5 because 5 adding up with a 10 can never add 5 can never add up with a different digit to add up to 10. And then we could also have 6's here. We cannot have 2, 3, 4 here. So I think we're guaranteed this has to have a 1, right? We can't have 2, 3, 4 here to add up to 9. And every other combination adding up to 9, 1, 2, 6, and 1, 3, 5 has a 1 in it. And then to add up to 7, it's 1, 2, 4. To add up to 8, it's 1, 2, 5, or 1, 2, 1, 3, 4. That eliminates 1 in the rest of the column. So this can't be 1. Where is 1 in row 1? It has to be there then. Okay. So this could be 4, 6, 7, 8, 9. We don't have another 1 available in column 1. So this could be 2, 3, 4, 6, 7, 8, 9. Also, one of these digits, so anytime you have 3 unique digits adding up to another digit, you have at least 2 of those digits adding up have to be 3 or less. And just it's basically by going through all the possibilities. 1, 2, 3 adds up to 6. That requires 3 digits from 3 or less. 1, 2, 4 adds up to 7. That's 1 and 2 require, which are 2 digits less than 3. 3 or less, I should say. 1, 2, 5 adds up to 8. 1, 3, 4 adds up to 8. Both of them have 2 digits 3 or less. As does 9, 1, 2, 6, 1, 3, 5, and 2, 3, 4 all require 2 digits at least from 3 or less. So we're guaranteed this is 1 and 1 out of 2 or 3, and this must be 2 or 3, which eliminates 2 and 3, 1, 2, or 3 in the rest of the column. So this can't be 2 or 3, it's 1, 2, 3, adding 4 with 6 as a possibility. Okay. What else do we have? These are all the same shading. These cannot be consecutive. The remaining digits of column 6 are 4, 5, 7, 8, and 9 with a guaranteed 4 in one of those 3 cells. These can't be 6 because of 6 in the column. We are guaranteed 8 has to be one of those 2 digits there, though. How do these work? Mm, 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 mm. Um, hmm. 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 Um, these are different shadings because otherwise we'd have a 2x2 area that's all the same shading if it weren't. So we'll make this pink, we'll make this orange. This must be orange also. Technically this could be pink. So one of these is going to have, oh, this cannot add up to 5 because we have 1, 2, and 3 in the column. So this must be false. And since this is false, this has to be the opposite, which means it's true. So we already have one change of shading here. We'll guarantee another one in one of these cells. So we cannot change shadings here. Therefore, these are all true. So we have these add up to 10 and these add up to 5 and these add up to 5. Well, that means this can't be 1, 2, or 3 because of 1, 2, or 3 in the column. So this must be 4 and 1 adding up to 5. That leaves this as a 2, 3 pair here. 2 can only be in a 1 to 2 ratio with 1 or 4, but that's already taken by 1, 4 in the box. So this must be 3 here and then 2 here, with 3 being in a 1 to 2 ratio with 6. So that works. Where is 1 in column 9? It has to be one of these two digits. Remaining digits in this box are 5, 7, 8, and 9. 4 and 6 eliminate 4 and 6 here. 2 eliminates 2 here, so this can't be 8. 1 eliminates 1 and 9 as a possibility. We have a 7, 8 pair in column 1, which eliminates 7 and 8 in the rest of the column. So no 7 here, which means no 8 there. No 7, 8 as a pair there. No 7 there. Okay. 4 eliminates 4 as a possibility here. So these two digits add up to 10, and it also has to be 2, 8, or 3, 7, because we don't have 1 or 4 or 6 available. And this 2, 3, 7, 8 quadruplet in row 9 eliminates 2, 3, 7, 8 in the rest of the row. So no 7 or 8 here. This is 5 or 9. That's 5 or 9. Okay. We have a 2x2 area that's all blue here, so this cannot be blue. This must be green. That must mean this is green also. So that connects up. This cell must be orthogonally connected to the rest of the blue, so it can only connect that way. We have a 2x2 area here that's all blue, so this cannot be blue, it's green. We have a 2x2 area here that's all green, so this can't be green, it's blue, which means these two must be blue also. 2x2 area that's all blue, this can't be blue, it's green. Diagonal here, that's all the same shading, so this can't be the same shading, so this is green. Oh, we already knew that anyways. This is X. Let's see. So these must be in a 1 to 2 ratio, which means this is 8 and 4. That's the only pair left. That makes that 8 there. So no more 8 here, no more 4 there, because of 4 and 8 in the row. No 4, 8 here, no 8 here. That means this can't be 4. This is 5, 7, or 9. 8 eliminates 8 in the rest of the box. So these can't be 8. This is therefore 3 and 6, which is in a 1 to 2 ratio with the other 3, 6. That eliminates 3, 6 in the rest of row 5. No 3, 6, no 3, 6. 8 eliminates 8 in the rest of the box here. It also eliminates 8 in the rest of the column, so this can't be 8. The 8 in box 3 then has to be here. That eliminates 8 in the rest of the row. So then we have to have 8 in one of these two digits there. Okay. Hmm. 8 is here. We have a 5, 7, 9 triplet in row 8, which eliminates 5, 7, 9 in the rest of the row. So this can't be 7 or 9. It has to be 4 or 6. That means this is 4, which means this has to be 6 to add up to 10. So 4 and 6, which means this is 1, 2, and 6, adding up to 9 here. So this must be a 1, 2 pair. 6 eliminates 6 here, so does 4, which makes that a 5. 5 eliminates 5 in the rest of the box and row. 5 eliminates 5 here also, so this can't be 5, it's 9. 1, 2 as a pair eliminates 1, 2 in the rest of the column, so no 2 there. It's 3, which makes that 2. 2 eliminates 2 there, so it's 3 and 7. 3 and 7 in row 9 eliminates 3 and 7 in the rest of the row, so this must be 2 and 8. 8 eliminates 8 there, so it's 7 and 8. No more 7 here because of 7 in the column. 7 eliminates 7 here, so this is 1 and 8 adding up to 9. That eliminates 9 there, so it's 7. No more 7 in the box and column. This can't be 7, so it's 4. No 4 here, no 4 here, no 4 here. 4 eliminates 4 in the rest of the row 2. So this is a 6, 7 pair. That 6, 7 pair, and the 9 eliminates 6 and 7 and 9 in the rest of the box, so this is 4. 9 eliminates 9 here, so it's 5, which makes this 9. That eliminates 9 in the rest of the column. So where's 9 in row 8? It has to be one of these two digits because of the 5, 7, 9 triplet here. That eliminates 9 in the rest of the box. Remaining digits of row 8 are 1, 2, 6, and 8. And 2 and 8 cannot be here because of 2 and 8 in the box. This is a 1, 6 pair. That eliminates 1 and 6 in the rest of the box. This is 2, 8 as a pair. 2 eliminates 2 here, so this is 8 and 2. That leaves this as 1. 2 is consecutive with 1, so this can't, and that has to be false, so this is 6, which makes that 1 there. 1 eliminates 1 here, so it's 4 and 1. 4 eliminates 4 here, so it's 5 and 4. 5 eliminates 5 there, so it's 9. And this can't be 5 or 9, it's 3 or 6. This 3, 6 pair eliminates, well, 6 eliminates 6 here, so that's 3, which makes this 6. It also makes that 6. So no 3 or 6 here, it's 5 or 7. This must be 5 or 7 as the only digits remaining in column 4. The remaining digit here is a 3. 9 eliminates 9 in the rest of the row, so no 9 here, it's 5. No 5 or 9 here, it's 7 or 8. Remaining digits in this box are 3, 4, and 5. 3 cannot be either of these because of 3 in the column, so this must be 3 here. That leaves this as a 4, 5 pair. 8 eliminates 8 there, so it's 7 and 8. 7 eliminates 7 there, so it's 6 and 7. So 6, 5, and 6 eliminate 5 and 6 here, so it's 9. That eliminates 9 there, so it's 5. This can't be 5 or 9, it's 6. 5 eliminates 5 here. remaining digits of column column 9 have to be 1 and 4, which does add up to 5. So this must be true. So they must be shaded. Okay. Now the green has to orthogonally connect, so it must orthogonally connect here. We have a 2x2 area that's all green, so this can't be green, that's blue. We have a 2x2 area here that's all blue, so this can't be blue, it's green. So this is the shading. So these cannot add up to 10. 3 is not consecutive with that digit here, so this cannot be 4, so it's 5, which makes that 4. 5 eliminates 5 there, so it's 7 and 5. 5 eliminates 5 there, so that's 7, and that's 5. 4 eliminates 4 here, so it's 1 and 4. 1 eliminates 1 here, so it's 2 and 1. 7 eliminates 7 here, so it's 9, which makes that 5, which makes that 7. And 2 can only be here. We also have a 9 with it. 2 and 9 does not add up to 10. So this must be 7, and this has to be an 8. But let's just double check. 1 and 8 add up to 9. 4 and 5 are consecutive, add up to 9. 3 and 6 are in a 1 to 2 ratio. 3 and 2 add up to 5. 2 and 1 are consecutive. 2 and 3 add up to 5. 1 and 2 are in a 1 to 2 ratio. 1 and 4 add up to 5. 3 and 6 are in a 1 to 2 ratio, so 3 and 6. 1, 2, and 6 add up to 9. 6 and 4 add up to 10. 3 and 7 do also. 2 and 8 do also. 8 is in a 1 to 2 ratio with 4, which is in a 1 to 2 ratio with 8. 1 and 4 add up to 5. 2 and 3 add up to 5. 1 and 4 add up to 5. And 3 and 6 are in a 1 to 2 ratio. For the greens, 8 and 9 add up to 17. 5 and 6 add up to 11. 2 and 3 add up to 5. 7 and 8 are not in a 1 to 2 ratio. 7 and 4 add up to 11. 7, 8, and 4 do not add up to 5. 5 and 3 are not consecutive. 3 and 1 do not add up to 10. They add up to 4. 2 and 6 are not consecutive. 1 and 3 are not in a 1 to 2 ratio. 6 and 9 are not consecutive. 2 and 9 don't add up to 11. And 5 and 7 add up to 12. So that should be satisfied. That is. Pretty cool. I don't... Would I consider this easy or challenging? I mean, I've done a whole bunch of yin-yang puzzles, so for me, it's not that hard. As yin-yang goes, this isn't that bad. So that is another thing there. I feel it's a little bit more challenging than easy, but would it be enough to be challenging level? I don't know. I'm not sure. For me, it's, I think, pretty much in between easy and challenging. I think I would default to easy, though, because other people label it easy. Anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.